concepts of science. We all love balloons. Blowing them, bursting them, and seeing them soar in sky is fun. Any birthday is incomplete without balloons, and so is learning science. Today we are going to study Newton's laws of motion with the help of balloons. For these experiments, we will need balloons, glue stick, empty thread reels, coin. Any coin will do. I have used a 1 rupee coin. Some used CDs and your lung power to blow the balloons. So let's get started. Newton's first law of motion states that a body continues to be in state of rest or motion unless an external force acts upon it. Now, to prove this, we will need a balloon and a coin. First, insert the coin inside the balloon. Like this, and now blow the balloon. Now blow the balloon and tie it. Do you see the coin inside? Okay. Now what we have to do is just hold the balloon and swirl it with your hand like this. When we stop the balloon, the coin doesn't stop. Do you see the coin moving inside the balloon? It's going down, 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 and finally it will fall. See that? Now, Scienty parents, does it remind you of something? Remember the well of death in circus that we used to see when we were small? The same thing happens here. Why doesn't the coin stop moving when we stop the balloon? It is because when we stop moving the balloon, the coin inside it still remains in a state of motion. It gradually slows down and falls because of the gravitational force acting on it. That is what the first law of motion states. Body continues to be in a state of motion or rest till an external force, gravitational force, acts on it. That's all for Newton's first law of motion. Okay, now Newton's second law of motion states that the acceleration of a body depends on the mass of the body and the force acting on it. For this experiment, we will need two balloons. One which is smaller but filled with water, and the other which is bigger but filled with air. Now let's see what happens when I try to push this smaller balloon with this big balloon. The lighter one runs away. Now let's try the other way around. I'll hit the lighter one with the heavier one. Now, did you see that? Why does this happen? It is because Newton's second law states that the acceleration of the object depends on the mass and the force acting on it. Now, the smaller balloon had more mass and hence the amount of force that it applied was also more. Whereas the bigger balloon, being lighter, could not apply much force, and hence in both the cases it was the lighter balloon which moved instead of the heavier one. Okay, so that's all for Newton's second law of motion. And now the third law of motion. Newton's third law of motion states that for every action there is an equal and opposite reaction. So how do we prove that? Well, for this experiment you will need a CD, a balloon and a thread reel. I've already set it up. All that I have done is I've glued this thread reel onto the CD. I'll place it here and I'll blow a balloon. Now I'll gently put this balloon onto the setup. Now put the balloon, fix the balloon on the thread reel like this and see. You know that the air inside the balloon pushed outside. That is, its action resulted in the motion of the disc. That is reaction. That's how for every action you get an equal and opposite reaction and the hovercraft started moving. That's all for Newton's law of motions with balloons. And now a balloony question for you. What would happen if I prick this balloon with a pin? Will it burst or stay as it is? Let's find out. One more. What magic gave superpowers to this balloon? Answer in the comments box and send to me right away. I'm waiting for the answers. Why didn't this balloon burst? And we'll meet next week. Stay tuned to your channel, The Scienty Kids.